Generally, the hotter that a material is, the less dense it is. The cooler something gets, the more dense it is. Because of the greater density, cooler materials sink below hotter material. There are some exceptions to this, but generally it works for everything. The main exception is water and ice. Modern theory of Earth's magnetic field is that the liquid metal, liquid iron, in the core is swirling partly due to the rotation of Earth and partly due to convection currents, partly due to the Coriolis effect. The moving liquid is carrying charges with it. The moving charges create magnetic fields. You're going to see this in your lab today. The north pole of this magnetic field is not the same as the geographic north pole, or the center of the Earth's rotation. Currently, the magnetic north pole is a few hundred miles away from the geographic North Pole, north of Canada. This means that compasses in Alaska actually point sort of east. The currents can change direction, the currents in the liquid iron, that is. The currents can change direction, so the magnetic field can change. It is currently moving towards the geographic North Pole. 100 years ago, the magnetic pole was moving about 15 miles per year. Now it's moving 55 miles per year. Nobody knows exactly why this is the case. The field can even flip directions. There is evidence in the magnetic filings of some rocks that indicate that compasses would have pointed to the South Pole thousands of years ago. It might happen again in the coming centuries. There really isn't any chance of it happening in our lifetime. The magnetic field has gotten weaker over the years. It is currently 90% as strong as it was 100 years ago. It's decreased by 10%. The mantle is also moving in convection currents. That look like a circular conveyor belt. It moves at about an inch per year, maybe a foot per year. At this rate, it would take thousands of years for material to make one loop. The heat that drives these currents may partly be due from radioactive materials. It may be partly from radioactive materials or heat left over from the originating time of the Earth. Draw convection currents in the outer core and the mantle. The currents in the outer core will be more complicated than what we draw, but the general idea. So down here, this is happening both in the mantle and the outer core. We're going to have hot stuff rising, and then it curls around and the cool stuff sinks. And right next to it, we have hot stuff rising and it cools down and it sinks. These are called convection currents. We'll have another one right over here, perhaps. Sinking, rising. That's in the liquid outer core. And it happens in the mantle as well. So you have hot mantle rising and it cools and it sinks. This circular pattern here is called a convection current. There are some places where the material and mantle is moving upwards, much more like a fountain than a conveyor belt. These are called plumes. The Hawaiian Islands are made by volcanoes produced by these plumes.